Alright, so we are in section 3.5, solving exponentials and log equations. So we want to recognize the fact that exponentials and logs are inverses of one another. They undo each other just like a square root and a square would, or addition and subtraction, or multiplication and division. They undo each other. So strategies for solving log equations. There's 4 types of strategies, whether it's an exponential equation or whether it's a log equation. That's going to be the first step that you need to determine. So the first one says equating exponents, which is an exponential equation. You can set exponents equal to each other when you have equal bases. Well, granted they're not equal now, but you can write them in terms of the same base. So this has a base of 6, but 36 can also be rewritten with a base of 6, being 6 squared, and then you have a power to a power, and you can multiply. Section 2 is to take the log or ln of both sides. So you do this when you have an exponential function again. So both of these represent exponential functions, but notice that this base can be rewritten as 6 squared. However, 15 cannot be rewritten with a base of 7. It would have to be 7 squared or 7 cubed, and that's not what 15 is. Third is that you have equating arguments, and we talked about that whatever's inside your parentheses is known as your argument for a log. So you can set arguments equal to each other when you have equal bases. Very similar to exponents. If you have equal bases, you set your exponents equal to each other. Well, when you have equal logs with the same base, you can set your arguments equal to each other. So 2x plus 8 equals 6x minus 12, and you would solve from there. And lastly, we have exponentiating each side, which is if you have a logarithmic equation, you want to take the inverse of that, which is an exponential, to get rid of the log. So you have to be careful with this one because you may have to use the product property, quotient property, or manipulate the equation another way to get it into this form. You want to make sure that you get the log by itself. So when solving this, the first thing that you would want to do is multiply through by 3 to get log base 5 of 12x by itself. Alright, so this first one is talking about, it's an exponential equation because we have x as an exponent. And we do have somewhat equal bases. They can be written in terms of the same base. So 64 is actually 4 cubed. And 16 is actually 4 squared. So we were able to write these two with the same base of 4. So now that you have a power to a power, we multiply. So we get 4 to the 3x is equal to 4 to the 2x plus 2. You have to make sure that you distribute that 2. From here, we also can say, well, they have the same base, so let me set my exponents equal to each other. Once you do that, we can then solve, and we get that x is equal to 2. I'm going to jump down here to 3 just so I don't just switch over to that side. We want to get the log by itself. Well, in this case, it's logarithmic because it has the word log. It's like your main hint. So we want to subtract 3 to get log of x squared is equal to 2. Now, because we have a log, we need to undo this log. And we do that by exponentiating each side. That's the vocabulary term that we're going to use. It's exponentiating each side. So we want a base of 10 because that's what my base is here. If this was a base of 7, we would exponentiate it with a new base of 7. But because it's 10, we're going to use 10. And we do that to both sides just like you would any other equation. You want to make sure that whatever you do to one side, you have to do to the other. Well, now the exponential base and the logarithmic base are the same, so they undo each other, and you're left with x squared is equal to 10 squared, which is 100. And you would solve this normally, so you take the square root of each side, and x is equal to plus or minus 10. Both of these answers